So, hello everyone, welcome to our class. Okay, so how are you all? I think you all are fine and you are doing good. Okay, so let's begin our class. Okay, so first you tell me what you observe here, like what is this, and what is this, and what is this, and what is this? What you observe? Yes, very good. So you can see protector, compass, pencil, scale, and that geometrical instrument. Okay, so very good. Now you think what we are going to do. We are going to do any construction. Yes, we are going to do some construction. Okay, so now what you have to do, you have to take compass and pencil, and you have to trace paper, like you have to take tracing paper and compass and other things, okay, to draw a circle. Okay, so here I will draw a circle. Okay, so here I have drawn a circle. Okay, so after draw a circle, you can see that this can be named as O, the center of the circle. Okay, we will name as a O. Okay, so after that we have to draw a chord AB. Okay, and we have to draw a chord AB. Okay, and then after, like, I will name this AB. Okay, now after that what we have to do, we have to fold like you have drawn on tracing paper, so we have to fold that tracing paper like this. Okay, so after that what okay, after like folding that tracing paper, what you can see over there, the line from O, such that like that way are folding tracing paper, a part lies AB or lies on AB or not. Okay, so here we will discuss about angle OMA is 90 degree and OM is bisecting the chord AB. So here we will come to know, like, this is the, okay, so this will be the image over here. Okay, so after that, now today we will learn about the today we will discuss about the theorem. Okay, like perpendicular from the center of a circle, a chord bisect the chord. So today our topic is related to theorem. Okay, so now you have to tell me what can we infer from this activity. Okay, so you tell me what we can infer from this activity. Yes, okay, so here we will solve theorem. So the theorem is here, like I will write here the theorem, like the perpendicular form of a circle to a chord bisect the chord. Okay, so here what you can see, that the theorem is given over here, the perpendicular form of a circle to a chord bisect the chord. Okay, so here what we will do, so here we will come to here we will do draw a figure, and we will elaborate that figure to this we will elaborate that figure to this theorem. Okay, so for that we can see that this figure is drawn like this. Okay, after that I will draw take as a midpoint. Okay, so like this will be A and B. Okay, so we can take this as O. Okay, so here we can see that triangle OMB we can name as OM, like triangle OMB is equal to triangle OMA, and you can see that the triangle is 90 degree. Okay, so here we can see the this is therefore that AM is equal to BM, like AM is equal to BM. Okay, So here we can see the this AM BM is equal to both of that. Okay. So again I have a statement for you, like chord will be bisect by the acute angle from the center of the circle. So here we can see that the statement is false, because it will intersect in the middle center of the chord. Okay, so the statement is false. Okay, so let's move further. Yes, okay. So now again you have to read this theorem whatever written over here, like the perpendicular form of a circle to a chord bisect the chord. Okay, so now what we have to do, now we will come to prove this theorem. Okay, for that I will drop the whiteboard first. Okay, yes, I have dropped the whiteboard. Now what we need to do here, we need to prove the this theorem. Okay, for that first I will draw a circle. Okay, then one chord, then after here I will name as O, and this I will make a triangle. Okay, so here I will make a one angle like 90 degree. Okay, so I will name this. Okay, so I will name A, B, and that will be the O. Okay, so here what we have to prove, we have to prove here like AM is equal to BM. Okay, so here what is the information that we can take as given in this theorem? So here we can take as a given like triangle OMB, like OMB we can take as a given. So given is triangle O MB is equal to triangle OMA. Okay, so this will be a 90 degree. So here we can see the angle, angle is making 90 degree angle. Okay, so after that what we need to prove, we need to prove here AM equal to BM. What we need to prove here, we need to prove AM equal to BM. Okay, so coming to the proof part, in triangle here, proof what, in triangle ABO and BMO, ABO and BMO. So here we can see that triangle ABO is equal to triangle BMO is equal to 90 degree. Okay, so here we can see that AO and BO equal is equal to same radii. Okay, so here we can see that OM is common. So what, triangle O, wait a minute, like AO is equal to BO, we can see as a same radii. It will be same radii. Okay, after that we can see that AO is equal to AO is equal to BO, it will be same radii. After that we can see that OM is common here, like this, and this is common here. Okay, so here we can see that triangle ABO, so here we can see that triangle ABO and triangle BMO is by right hand RHS rule. By it will be what? It will be by RHS rule. So here, yes, so here we can see that this is like so here we can see that the theorem is proved, and here we can see the two triangles are congruent. So okay, so now we have to see that what we we use CPCT in this. Okay, so we use CPCT rule. Okay, so after that we can see that AM is equal to BM. So this will be as CPCT rule. So here the theorem is hence proved. Okay, so I hope everyone is clear. Yes, please note down this theorem. Okay, proof of this theorem. Okay, so again I have question for you. Like I have question like I have circle. Okay, in circle there is one chord, and in between of this chord there is one intersecting line. Like you have to tell me, is this construction possible, and if this possible, then tell me the region. Give me the region. So we can see this instruction is not possible. So okay. So let's move further. So moving further, okay. So again, I will give you one theorem and you have to rate that theorem. Okay. So first I have to rub this whiteboard. Okay. Okay. So here I will write the theorem. Like the line drawn through the center of a circle to bisect a chord is perpendicular to the chord or not. Perpendicular to the chord. Okay, so student, now we will prove this theorem. Okay, so for that what we need to prove here, like in this theorem what we need to prove here, like first we will draw one circle, then here we will make one triangle like this, and we will name as, like this is a middle point, so we will name as O, and here M, and this one AB. So here now tell me student, like what we need to prove here. We need to prove here triangle AO, sorry, so here what we need to prove here, like a triangle OMB is equal to triangle OMA is equal to 90 degree. Okay, so very good. Now you now student, tell me what we can take as a given. So what we can take as a given here, like AM is equal to BM. Okay, yes, so this can take as a given. Okay, so very good. Now we will come to proof of this theorem. So for that, to prove, we will start the proof. So here we can see triangle OMB is equal to triangle OMA equal to 90 degree. Okay, so here we can see that the given this. Okay, now we come to down, like AO is equal to BO. Okay, so we can see this will be a same radii. Okay, then after that we can see that OM is common, like OM is common in both. Okay, so we will write this as a common. Okay, after that we will see that triangle ABO and triangle BMO is by SSS rule. Okay, so here we can see that, this is like this theorem is by SS rule. Okay, so now tell me, we have proved that these two triangles are congruent. Now what to do ahead in this theorem? Okay, so here we can see that we use CPCT rule. Okay, so after using CPCT rule we can see that therefore triangle OMB is equal to triangle OMA is CPCT. Okay, so we know that triangle OMB plus triangle OMA is equal to 180 degree. Okay, so or we can say that two triangle OMA is equal to 180 degree. Okay, or we can say that two triangle OMB is equal to equal to 90 degree and A equal to 180 degree. Okay, so here we can see that triangle two triangle OMA, so like this. Okay, so here after that we come to here, therefore triangle OMB is equal to triangle OMA is equal to 90 degree. Okay, so here this theorem is hence proved. Okay, so I hope everyone is clear with this theorem, how we prove this theorem. Like we can see that AM is equal to BM, so this theorem is proved. Okay, so again I have one statement for you. Now you have to tell me which statement is true. Like the first statement is that the perpendicular form of the center of a circle to a chord bisect the chord. Okay, then the line drawn, the second statement is that the line drawn through the center of a circle to bisect a chord perpendicular to the chord. So here you have to tell me which which statement is true here. Okay, so I think here we can see that the second statement is true. Yes, because the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Okay, so I hope everyone is clear till now. So let's recapitulate our today's class. Okay, so our today's class we have learned about two theorems and we proved that theorems. Okay, like first theorem and second theorem. Okay, so after that I have homework for you. Like there are two circles of same center O but different radii. Okay, so both the circle are having one chord AB and PQ parallel to each other. To prove that the line from the center O perpendicular to chord of one circle is bisecting to chord of another circle. Okay, so again I have one activity for you. Like you have to draw the 5 circle on chart paper with same center O. Circle are in successive order of their radii by variation 2 cm. Color each circle with different color and draw one chord or bigger circle such that it should have all the chord of remaining circle on it. Now draw a perpendicular line from the center to the chord of the smallest circle. You have to find out whether that line is perpendicularly bisecting chord of all the circle or not. So I hope everyone have written this homework on your notebook and you will solve this question. Okay, and we will meet tomorrow. So till tomorrow, take care. Okay, so bye and take care. Thank you everyone.